Well, hey everybody, welcome to my Twitch channel. We're going to do something different today. No Dwarf Fortress, no video games, no just random coding for fun. What I want to do today is I want to do some work, some coding for work, and I want to do it in plain view of everybody else, so you can see, you know, this is what it's like to be an SRE. This is what it's like to be a senior IT engineer who, you know, isn't perfect at everything. Is still trying to figure things out. I gotta look up syntax all the time, and regexes. Spend time with regexes and the regex testers online. Like, it doesn't matter. Like, you're so used to seeing all these really polished solutions, people posting online, and they're seeing. You know, what everybody's already done, what they've succeeded at. You go to presentations and people talk about all the amazing things that, that they've done, and to their credit, that's impressive, and they've done some really good work, but it's already polished and it's done, and looking at it from out in the audience, it can feel like, you know, you don't really know, you don't know how to do that, or you're not good enough to do that, and that's not true. I think everybody can get there, and so I want you to see, you know, this is what it's like for me to be a programmer and to be relatively new at my team, and to be relatively new at Golang. And I'm going to try to work on this card today. We already got a bunch of people in the chat. Hey, what's going on, Ryan? It's good to hear from you, man. And Sub, thanks for coming. Yeah, so we're gonna go through an operator here. My task today is to try to figure out how to make this file integrity operator that we use at work in OpenShift, or we're going to use at work in OpenShift. How to make the reports a little bit more consumable, easier for a machine to read and report out to other folks, right? So everything isn't everything is not a perfect Stack Overflow post. There's a lot of work that goes into everything, and I think Ryan here, Cook the Ryan, knows all about that. He spends all his time doing amazing things, but I'm sure he puts in a heck of a lot of work to do it. So from the outside, he looks like he's a pro, though, and I think that's what makes a pro. You put in the work, you learn, and you fail, and you learn again. And for me, it's important to be able to fail in public, to fail visibly for other people, and to not try to have a stigma to that. You don't need to be perfect. You don't need to have all your ducks in a row to get online and talk to people about something. So that's what we're going to do today. So I've got VS Code open here, and we're going to get started. We use, or at least my teams that I have been on recently use code-ready containers to do development locally for operators. So I've got, I believe I've got CRC running already. And I actually recorded a video of myself for this, you know, practically programming stream, and wanted to get an example of how to get CRC set up so people could follow along. And I ran into a whole bunch of problems. I struggled to get it working on this computer. This isn't my work computer, this is my home computer. I really struggled. The video was terrible, and I almost threw it away, and then I thought, no, this is exactly what I need to show people. I need to show people that, like, oh, I forgot to turn on VMware or VM virtualization technology in the processor in my BIOS, right? So CRC wouldn't start, and couldn't get my Go path to work right, and so I've got that recording, and I'm gonna edit it just for time, but I'm gonna share that as well on the YouTube channel. So yeah, we got CRC running. So I believe I can just say OC project, and yeah, so we're in the file integrity operator project that I've created already. And the way the file integrity operator works is there's some YAML. You give it a YAML file to create a file integrity custom resource. This is all within OpenShift, which is Kubernetes plus Kubernetes. Let's say Kubernetes for enterprise and for developers. Not that Kubernetes isn't, but OpenShift just makes things a lot easier. Adds some layers that are super nice. So I'm going to look at the browser here. We're going to pull up the CRC file integrity operator stuff. File integrity. Because you know, in the whole plan to get this thing up and running and start streaming this with you, I forgot entirely to copy any of my files over from my work computer. So we're going to go ahead and crib a little bit too. So right, so the file integrity operator uses file integrity objects. So and this is an example of one. And you have a node selector that tells it to run what to run on. The idea is the file integrity operator runs AIDE or AIDE, which checks to see if files have changed since the database was built, and it kind of allows you to see if something has modified those files, and it can be maybe an automated process, maybe a user, or maybe a malicious actor. So you want to get the reports of since the last time this ran, the file has changed, and you want to hang on to you know, important files, files you don't think should be touched or that need to be consistent across runs. And this will check it. This will run a little agent across all the nodes in your Kubernetes or OpenShift fleet and check the files that you give it. So by default, it's going to work for some Red Hat CoreOS files, a good set of defaults, a whole lot of the read-only file system and the important files in there. But we got to turn it on so it'll do its thing, right? So we have this file integrity object. We're going to call it example file integrity because we're not actually going to just do workers. We want it to also do infra and master nodes. It's already more complex than my APCS. Is that AP Computer Science? Yeah. This is just OpenShift, man. We haven't even gotten into the code yet. Yeah, OpenShift is complex too, and there's Kubernetes as well. There's a large learning curve, but you know, if I can do it, anybody can do it for real. So, yeah, and then we also need to allow for some taints that we have. So currently, not on my local machine, but in our normal fleet, we taint things from running on master nodes and infra nodes. So there are a couple of taints to apply for that, and I've got to look that up because, you know, like I said, I don't remember these things off the top of my head. I don't have everything memorized. We need to add a toleration for those taints. So let me pull that up as well. And this is what my daily job is. I'm looking things up as much as I'm doing anything else. All right, don't see anything there. use Java in your AP Computer Science class. Yeah, I think that's how they teach a lot of computer science classes. Java is kind of a useful multi-platform language. That's certainly what everything was taught in when I was in college. But I didn't take any computer science classes in college. I was a music major, and so I didn't take any Java. I didn't learn any programming until about really about 10 years ago, maybe less. And look at me now, Mom. I'm an SRE at Red Hat. Alright, so I don't see the documentation for the tolerations yet. Let's see. I had looked it up. I don't see where I put it. But that's fine. We can figure that out. Actually, I might be able to pull it off my laptop. Let me go ahead and try that. Nope, apparently not. Alright, let me look it up on Marvin. Pro tip, you have to be running an SSH daemon to be able to SSH into the machine you're trying to SSH into. Or, I guess more accurately, you have to be running the SSH daemon on that machine. Wake up. There we go. Yeah, that's what I was looking for. Alright, so we need tolerations here. I'm going to set the config to a grace period of 900. I think that's the default. So that's 900 seconds, or every 15 minutes, I think. That's how often the node, the aid scanner is going to run. And we want to tolerate. Everything's spelled right, yeah. So one thing about computers, you know, they can't guess what you want. They got to go ahead and tell them literally what you want. Right, so we're going to tolerate master node taints. And we're going to tolerate infranode taints. And I believe out of the box that the file integrity operator already tolerates master node taints, just in the background. But it does not, by default, cover the infranode taints that my team runs on our infranodes. So, right. So we got this is the YAML we're going to use to create a file integrity object, right? So we're going to create a kind file integrity of the name file and example file integrity in the namespace OpenShift file integrity, and otherwise it should just start running. So this project is really cool. It uses a makefile for a bunch of stuff. And instead of looking at it in the terminal here, we do have a whole editor. So let's go ahead and look at the makefile in the editor. Right, so this makefile has a ton of stuff, and one of the great ones is it's got a run target, which is pretty neat. We use the operator SDK for our operators, and the operator SDK has a run local option, which means you can run this particular operator bootstrapping that framework without having the operator like installed into the cluster. You're just running it in the cluster, having it watch the cluster and interact with the cluster, but it's running locally on your machine, right? So this gives us the opportunity to say make a run, and it spins up the operator that I have in code here in VS Code. In this directory, this version of the operator right here is what's running. So I'm going to run it here in the terminal real quick, and then we're going to switch to a different terminal to work with the the command line a little more. So say make run. And so this is different. Let's see, why is it? It's trying to download operator, so I guess my go path is messed up. Let's see. Yeah, okay. So I'm using GVM for Go, and I don't have a default environment on my home machine, so GVM list. Okay, so I do have Go 1.15.6 installed here. Use Go. There we go. Now I should have a Go path. Great. Now I should be able to say make run. Yep. Okay. So now, because the Go path is set, it knows that it's got the operator SDK there, and we can spin up the operator, and it's starting here. And what is this? Okay, so yeah, again, this is my daily work. You run into things, you have to troubleshoot them, go around the long way to get to what you're trying to do. Okay, so if kind is a CRD, it should be installed. Right, so what I forgot to do was install the CRs for this. So if you look here in deploy CRDs, we've got these definitions that define the CR objects, right? These are custom resources in Kubernetes. And I haven't actually installed these into the Kubernetes inside of OpenShift yet. So I think usually you could just say, you know, OC create or kube control create and pass it to the one of those YAML files. I think there's a make target for that though. So let me look at the make file real quick. There's something like deploy local. Yeah, okay, so deploy CRDs. Yep, so it looks like deploy local, make deploy creates the CRDs and a namespace if it doesn't exist. So that's what we needed it to do. I should have run that first and prepared this project for the file integrity operator. So make deploy. There we go. So that created our roles and our cluster role bindings and the deployments that we need for the operator itself. And then we can say make run. There we go. And we're going to get this error about metrics because it turns off metrics when running locally. There we go. So now the reconcile loop is started, right? So the reconcile loop within this operator, if you're familiar with operators or controllers in OpenShift, basically what it does is it loops around over and over and over again, and that's the reconcile loop. And each time it loops, it checks on the things that it's supposed to be watching, looks for new ones or changes to old ones, and if it picks up changes or new things, it decides how to act on that, right? So right now it's going to loop, and it's waiting for a change, and when we make a change, it'll pick it up and start working on it. So we got this thing working, and we're going to go ahead and make a new terminal. And we should be able to say OC project OpenShift file integrity. Already there? Okay. And yeah, it looks like we've got a pod running and a service. So this is the operator itself. The operator is running. It's waiting. This is what was the output of the previous terminal. Is this pod, right? Running inside that terminal, or that in the cluster, and it's waiting for us to create that file integrity object. So we have the file integrity object locally. It's the only change in this repo because I just copied it here. Yep, file integrity object. So we're going to go ahead and OC or kube control create this. Okay, so there's an error in my YAML. Is that not the... Yep, there it is. Yeah. Is that not the default, like... Is that correct? Yeah. There needs to not be this on the end. That's like the default war cry of anybody working on Kubernetes. Is there's an error in my YAML. There we go. So we've created the CRD, or the CR. We need to give it a type. This is a type of file integrity. Yep, so it's there, it's 18 seconds old, and let's go ahead and describe it. We'll take a look at it. So it looks like it's initializing still, so that should be, I believe it's creating, daemon sets and stuff that it's expecting on the nodes that we're expecting it to run on. There's only the one node, so I'm not sure why it's still initializing. Okay, this is the operator. Yeah, so the daemon set for the example file integrity is not running any pods, but it doesn't expect to. So I've got another mistake somewhere in my object. Let's see. Let's take a look at this object here. How is that different from my laptop? And currently we only had worker and master, so maybe we can, oops, pull that back up. We'll save that. Let's see if we can apply that and make a change. There we go. Now let's check the daemon set again. Oh. Whoa. Nano. Nano is the default inside this VM, huh? That's unfortunate. I gotta remember my Nano key bindings. This has been a while. But let's see, we can look. Nope. We can look. How do I undo? Control M? Control. There we go. Alt M. Okay, so it looks like this didn't pick up the change to the node selector, so that's something we can write down for improvement later. We need to have the daemon set be updated when the operator file integrity object is changed. Alright, I got that written down in my notes, and we can fix that later, hopefully. Alright, so we're going to leave, we're going to go ahead and just go ahead and delete that example file integrity. Alright, and That should have deleted the, yep, that deleted the daemon set. But we still have the operator running. That's fine. Alright, so let's, I think the file integrity is how we want it now, though, so we can just create a new one. It was the implying that was problematic, I think, so. Now creating this new one should create a daemon set. Yes, okay, so we got a daemon set that desires a single copy, single pod running. There's currently a pod running and everything's up to date. It's not ready yet though, so we'll wait for that. Now it's ready. Okay. So if we say so our example file integrity is progressing. Or not progressing, it's a loaded term, right? In Kubernetes. It is there. It's aging nicely. Let's take a look. And so the phase is active. That means it's running. So we should have the pod running. And let's take a look at the logs. Great. So it's initialized. It created that first database of file integrity operator of the files that it's watching. It created the database of the content of those files, so it'll know when there are changes. So in 15 minutes, it should run again and see if those files have changed. So what we're doing is we're looking at trying to figure out, or let me back up. When it does run, if it finds a file that has changed too much, the file's too large, instead of showing the output in its report human readable, it shows the output from the A daemon gzipped. And there wasn't an easy way, as far as I could tell, to consume that. So I want to figure out, first of all, where it's doing that in the code, and then figure out if there's a way to indicate when that's going to happen, or if we can try to just look into it a little bit and investigate how we might make this a little bit more useful in terms of deploying to a fleet. So this works fantastic for a single person or a couple of clusters. An ops team running a couple of clusters, they can get alert that the file integrity check has failed, and they can go and see the object, the config map that's created, and shows what's changed. But if you're running, say, 100 clusters or 1,000 clusters, the way that my team is involved in, you can't manually do that. We need to be able to get those results in an automated way. And at the moment, they're stored in that config map, and they may or may not be gzipped. And the indication that the integrity check has failed is probably good enough to alert us to it, but we need to be able to consume the contents of the failure. So we're going to look into the code, and we're going to do that here in VS Code. So we've got that running. We're just going to let it sit and do its thing. But inside of the package and the controller should be the stuff that is managing this operator. So controller.go looks like the default. Alright, so we have file integrity, add file integrity. So this is just init functions, so they run before other stuff. Yep. Alright, so probably within here we've got node controller, file integrity. The file integrity is what we want, I think. File integrity controller. Yeah, so this looks like the meat. If we look in here, here is nope, that's not the reconcile loop. This is dealing with config maps. There we go. This is the reconcile loop for the controller. Right, so we're going to look for something that indicates like a scan. So let's see, we're going to get the integrity instance. Get the daemon set. Get the config map if we need one. Okay, this is checking if there's a new config. Yeah, so if you make a change, like if you tell the operator to reinitialize the database for, say, a file changed and you're intending for that to be a thing, you can have it rewrite its database and say, this file is cool. So, or these, the files that you have right now are in a good state. That might end up being not necessarily ideal, but I don't think that's an operator problem. That's an aid thing, right? If you reinitialize the database, you have to be able to swear that everything is currently exactly as it should be right now. And I guess you could do that by comparing the original run, like the output of the run. If you run the integrity check and you see that only a single file has changed, you could return that file to that state. I guess you could reasonably assume that no other files have changed in that time span, and if you rerun the check and it says everything's good except for that file that you wanted to change, reinitializing the database is alright. But if you're running, something that's been aging for a little while, or maybe something changes when you reinitialize the database, if you don't double check, then you could get a file that has changed, is not the state that you're expecting. Yeah, that's part of it's part of a problem with just drift in general, right? That's a concept in SRE and operations. It's just the longer something has been up, the more of a chance is that it's going to be different than what you expected. Accidentally or on purpose. Yeah, so at a previous job we ran containerized instances. We weren't running, I was running OpenShift, but in a homegrown container orchestration system. We also, every 7 days, would have each application be torn down and re-rotated so that we could force that and ensure that everything that was running was exactly what we had expected it to be. And that actually worked kind of nicely after we got over the hump of making sure that we could handle things being torn down randomly and regularly and recreated. So I was inspired by somebody at DevOps Days in Raleigh who works for a company, and his team had decided that any EC2 instance that had ever been SSH'd into or had reached a certain age was going to be torn down and replaced just automatically. And I thought that was brilliant. You can't ensure that that thing is the way you wanted it if anybody's ever SSH'd into it, or if it's more than a certain number of days. There's just too much drift just from existing. And I thought that was really, really kind of a cool take. So that's a problem with this, I think, too. But that's the thing with the concept in general, not necessarily with this operator. And it's in practice, I don't think it's necessarily going to be an issue. But so back to the topic of this stream. That was an example of my thought process taking a completely different tangent while I'm supposed to be working on this thing. And yeah, I kind of do. That's what it looks like to work. That's what it looks like to be me. Don't feel bad if it's hard to concentrate on a single thing, or you get moved off into a different direction and you're thinking about a whole other issue. That's just life, man. Alright, so we got it's the force reinit for the loop. And okay, I think this is getting... Okay, it's creating an empty daemon set, and it looks like it's populating it. So this would be if you told it to create the file integrity object. It's going to populate the aid daemon set. Yeah, and it looks like it gets the existing one as well, so I believe that's what that function is. Let's go check that out. Oh yeah, this might be the, I'm sorry, this is the default it looks like. It's the spec for the daemon set. So, oof, I got lost now. I'm gonna have to find my place. Here we go. So it looks like it's comparing them. Which I believe is correct. I was looking at this recently. Yeah, this is a part that I had worked on a little bit earlier. Making sure that the arguments and the images, namespace, and whatever were updated when there was a difference between the default and what somebody had provided, right? This, I think, is where the node selector... See, this should have, when I changed those node selectors, this should have triggered that restart. But I wonder if... I'll have to retest that. That should have triggered the redeployment of the daemon set. So we'll double check that that works the way I think it does. It certainly adds them, or it did when I was testing it. It added node selectors and restarted the daemon set, or recreated the daemon set when we added node selectors to the object, the file integrity object. But just now when I deleted them, it may not have updated it, so we'll double check on that work. Okay, so that looks like that's the end of the reconcile loop, and I did not... Hey, Stealth King. Yes, let's learn, man. Let's learn together. Yeah, that's what we're doing here. We're trying to learn, and we're trying to do some work, and it's not pretty, but that's what work is. So I'm looking at this reconcile loop, and I don't see where the pod is run, but it's probably not, is it? It's is there a job? So okay, so there's a pod. This creates a daemon set which creates pods that run the aid process, and you give it a timestamp for how long to run. So I wonder if inside the pod it's just hanging out and is running itself every couple of whatevers, rather than there being a loop or some kickoff from Kubernetes. Yeah, so let's take a look at this. Alright, here's the pod spec. Well, the description of the pod, which is effectively the pod spec. So these are arguments to the entry point. There's the interval, so I would be willing to bet that the entry point of that pod is the aid process. So this pod just hangs out, and every 900 seconds the process inside of it does a thing. So nothing inside the operator is kicking off that scan. So that's going to make this a little harder to troubleshoot. How then does this get the contents into that config map? I wonder if it fails, does it? I don't know, we'll have to look. How does this pod get the contents of its logs back into a config map? Well, it certainly got namespaces, so it knows about stuff. So it must not be running a raw aid inside this container. But that means probably somewhere inside this is a Docker file for the file integrity operator image. Which might be the same thing as this image that we've got. This there's aid, yeah. Okay, there's images. Well, that's easy enough. Yeah. So it's basically a Rel 8 container or a CentOS container or a OpenShift origin container with aid running. So how does that get into, okay, log collector, that's probably it, let's see. Okay, so log collector is something else. But that's probably what we're trying to find. We need to find where this is. So is this file, I wonder? This is, okay, it's in this operator, build output bin, file integrity log collector. Okay, and this, I guess generates that bin file. So there's something in here, I guess, that is the log collector. So where is that built? Separate from the operator. Actually, let's look at that make file. That's the one that has the, oh, what was it called? Just had it. The make target, yeah, make log collector dash bin. So let's see what happens there. No. Okay, it's not in that make file. So is this maybe something else? Am I going down a rabbit hole in the wrong direction? That is entirely possible, and is you know, effectively a normal part of my workday as well, and I think it is other people as well. So yes, am I going down a rabbit hole somewhere, chasing the thing in the wrong direction? That's probably a thing. So let's see. So we have from the goto set. The file integrity operator, copy everything inside. Yeah, I mean, there's nothing special here, right? It's make, did I spell it wrong maybe? Yeah, I really don't understand. There's no... log collector bin in the make file, but it's clearly using a make target for that. So I wonder if we have like an imported configuration or something. Let's take a look. Yeah, this might be a dead end, so we might have to look somewhere else. But that's also part of the job, right? You got to dig in and figure out how things work. Maybe your suspicions take you in the wrong direction. Hey Sal, yeah, sorry, we're not doing Dwarf Fortress today. We're doing a new thing that I'm trying. Want to do a stream maybe twice a week that shows me working, like doing actual work, and kind of showcase a little bit about what it's like to be a 20-year IT veteran, still kind of learning and failing at things and trying to figure things out, because I think a lot of what's shown online is people who are perfect and polished, through no fault of their own. I think that's just what is expected. But it makes being a spectator at presentations and watching Twitter and stuff makes you think maybe you're not good enough, right? And maybe they look at me and they can say, "Oh yeah, this is like me," going down the wrong rabbit hole and failing to figure out how something works. So that's what this stream is going to be. My good buddy Steven from Horseshoes and Hand Grenades, the excellent podcast, by the way, suggested that I go ahead and just do this stream right on the same place that I do the Dwarf Fortress and the gaming streams, because that's kind of who I am, and no need to hide that as well. Yeah, I'm a Dwarf Fortress player, and I'm a software engineer, and that's cool too. So, not that there's stigma to either of those, but yeah. So that's what we're doing today. We're trying to figure out where the logs from this aid pod, how they make it into the config map. And it looks like it's got its own binary, but I can't for the life of me figure out how that binary is built. So we have let's go back to this Docker file real quick. Alright, so we got the image. This is clearly the file integrity operator workdir. It's copying everything locally into the same spot inside the image, and then it runs make log collector bin. So it's got to be in the make file somewhere, but I don't see it. I wonder if it's maybe the make target is a variable. I think I saw that earlier. That's not something I had seen before. Yeah, this is a make target, isn't it? With a variable in front. So maybe there's a something dash bin target. Hey, Adam of Geekheim. If anyone comes in and yells "add a semicolon," that's your fault. All right. Well, I will blame you for that. There's there's probably there's semicolons right here. Maybe that's the thing. I'm gonna take one of those out. Honestly, that is a right there is a redundant semicolon. But I didn't write it, so I'm not gonna take it out. Perfect timing, though. Yeah. Forgot a quote. Yeah. I think we need a emoji for when somebody's being serious and when they're joking, because now I'm going back and thinking like, did I forget a quote somewhere? Yeah, so let's see. Where is... I don't see anything that looks like it would be like a variable build. Okay, so I cannot figure out where this make target is coming from. So I wonder if we can search. Let's see if we can find it in some other way. Let's see. Okay, so we got... Okay, it looks like we got log collector stuff. Oh, you know what? Maybe I should do that. Maybe I should read the documentation. Emacs. Oh man, Adam McGeekheim, are you trying to start a religious war in this chat? All right, let's see. Maybe we can. Let's read the docs. Something about status, log collector. I think I can view this in a preview. There we go. Oh man, it's all Vim, all the time. At least for me, it's just for convenience. Honestly, another friend of mine, Nate Childers, he came in at a time when I was very like, this is the right way to do things. You know, Vim is the right thing. This is the right way to set up a server. This is the right way to do this. And he taught me to use the tools that you need. Use the tools that work for you, and do things the way that works for you. And that's true. That's true. Hey, Mello, how's it going? Good afternoon. No gaming today. We're doing a little bit of programming. All you see is a black screen. Anybody else seen a black screen? Maybe try reloading. Maybe I don't know. Or maybe add it. Yeah, I don't know. Adam says Twitch was having trouble with him too. You see me okay, Stealth King? Alright. Yeah, I think I was following Mello earlier this morning and she was having some trouble, so maybe yeah, maybe Twitch is just behaving poorly. Yep, sounds good. Sounds good. Okay, so let's see. There's something in this document here. There we go, log collector. So, the file integrity controller deploys a daemon set that runs a log collector container. Okay, well that explains that at least. This container runs a daemon on each node that periodically places etc Kubernetes aid log into a config map. The config maps are labeled in a way that can be identified easily. Let's see. Yeah, Stealth King, I was thinking it's probably not me if you can see me. Yeah. The config map controller processes the config maps created by the log controller daemons. Okay, that's fine, but anything else about log controller? Okay, so there should be a log controller container Do we have a log controller container? We have the aid pod. Does this have a log controller in it? So this could be a pod of multiple containers, which is kind of a cool concept that OpenShift Kubernetes has. You know, I like to think about, or you know, a lot of times you think about containers as being single containers working on their own, but Kubernetes concept of pods allows for multiple containers at a time. So, okay, here's the container definitions. And as I say multiple containers at the same time, multiple containers together, working together. I'm not explaining it well, but yeah. Alright, looks like there's just the one container here. Unless maybe that's... So it's certainly talking about the same file. Hey Mello. Yeah, sorry. I'm glad you could see though. Thanks for stopping by. I appreciate it. It's good to see you. Yeah, so... Okay, so no real clues here. Let's see. There was also the log collector information. Where else? We just searched for it. This may be a case where I need to abandon this line of search and actually talk to a human who's done something here. And maybe they can point me in the right direction. But let's see. This is also very much like normal work, right? Oh, so Mello, this is a new type of stream for me. This is something I've called practically programming, and I wanted to kind of show off, not show off, but show people what it is that I do for work and how I work, because a lot of times presented online and in presentations, everything is perfect and polished, and it's easy to get the idea that you're not as good as everybody else, or you're not as good as you should be to do a particular job. And especially in IT, that can be a thing. So I wanted people to be able to see me as a professional SRE, and right here, right in the midst of struggling to figure out how this thing works. Not polished, not perfect, and it's perfectly acceptable. So that's what we're doing here today. This is my job, and I'm doing this after work, but you know, for work. And that's what this stream is going to be. So, hey, thanks, Mello. I appreciate that. I hope it helps some folks. And even if it doesn't, I hope maybe people will enjoy just hearing somebody ramble on to themselves and type on a mechanical keyboard. So that's very much what my Dwarf Fortress stream is as well. So, all right. So let's see. We're looking for the log collector stuff. This looks promising. Command manager log collector. So clearly something is running. It looks like it's running even in the same binary. So log collector is built into this thing, I guess. So let's see. Command. Let's look into command. If I find it, there's command. Okay, log collector. And that's not helpful. Okay, so this is probably Cobra. Yes. Maybe not Cobra. Does it have root? I don't see a root, so this is not Cobra, but something similar. No, it is Cobra. Okay. So this is a Cobra is a thing, a package in Go that somebody wrote that makes it easy to write command line utilities. And it looks like the operator, this operator under the covers, is using it, and that's cool. That means that, you know, when the container image starts, they can have it run the command, and that's how it kicks off the operator. So this is, yeah, this is the parent command, and the run operator function, and there's probably more commands added further down. Is that metrics maybe? Something related to metrics? Serve metrics, yeah, okay. Create the metric service, yeah. Okay, so that's all about metrics. But I imagine that means log collector here adds itself as a command. Okay, so let's see. This is the log collector. So func log just returns, looks like a time formatted, like a date stamp, I guess, formatted log, and then a debug log, fatal. Interesting. Get non-empty file in inode. Teacher gave you a C in coding class because she felt bad for you. Aw, don't feel bad. Everybody has to learn. That's what we're doing here. I don't know how to... I'm just now learning, not just now, but only recently learning this programming language. And I am relatively new in the last, I don't know, 6 or 7 years to programming in general. So, yeah, we're all learning here together. That's what this whole stream is about. I guess you didn't say you felt bad, but if you did, don't feel bad. Okay, so... Excellent. Okay, so here is... You're learning this now. Hey, you know what? I'm learning this now too, actually. So... We're, like I said, we're here together. All right, so this is what I was looking at. This is exactly what I was looking for. This, I guess, is the function that determines if the thing needs to be compressed. Got sidetracked into website building. Hey, that's a good thing to do. It's certainly a good thing to learn, for real. Here, I remind you of Bob Ross. Well, that is probably the nicest thing anybody has ever told me. Thank you. We got some happy little code. We're going to put a happy little semicolon right here. Yeah. Alright, so needs compression. This, I bet you this is what decides to compress the contents of the config map. And, okay, here's... This is the log config map. Alright, so this is what I don't understand. So, this thing, I guess, creates a config map with the output of the log from the pod. I guess it's running together in the same pod, so that makes sense. It's just another process running in the same pod. Actually, we might be able to check that. Let's see if we can get into this pod. Let's see if we can figure something out. Well, that doesn't help. Clearly it's running in this, maybe it's running in the same process? Oh, no worries. Please do. Have a good dinner. I appreciate you hanging out. Yeah, so it looks like we got a single process running in the pod. So either the log collector is running in that process, or this pod is not the one that has the log collector in it. But let's set that aside for a second. We see that the log collector here has the function that compresses the contents of the log, and it probably creates or fills out the config map that has the values that we need. Yeah. So content key, contents. What are the contents here? It's just a byte string. Okay, so this is, yeah, the contents or the compressed contents from the byte slice. So where do the contents come from? Definitions? No. Implementations? References? No. Okay. How about this? Something sends calls needs compression. Where is that? Okay. Log collector main loop. Okay, this is what we're looking for. Log collector main loop creates temporary status report config maps for the config map controller to pick up and turn into permanent ones. Reads the last result reported from aid. Okay, well this is definitely what we're looking for. And it's reading the result from a channel. Wow, this is far more complicated than I expected it to be. I don't know why that's the case, because you know the folks that do this, that are making this operator, are super smart and very good at what they do. So this seemed like it was a simpler operator at first, but it's definitely more complicated than I thought. So I'm not sure why it creates a temporary status report. It probably creates a temporary status report because each controller is really only supposed to write the thing that it has control over. So if this wrote a config map and the config map controller wrote the config map, they might butt heads. So this probably creates a temporary config map. And if it exists, the config map controller can read from it and create its own permanent config map. But I don't know if that's the case for sure. That's my thought. Okay, and it gets the last result reported from aid. Well, the result comes in here, and that's a channel. So something is sending in the result through a channel. RT, I guess, is the name of the channel. No, it's a daemon runtime. So the result from the daemon runtime sent through the channel. I gotta be honest with you, this is where my being new to Go is new-ish to Go. I'm not super new, but I don't have a solid understanding of channels. And I realize that's one of the big, pluses of Go, but I haven't had a chance to use them yet, and I don't really know 100% how they work. But something is, I guess, retrieving. Something is sending to rt.result, which I assume is the channel, and that is being retrieved into the last result variable. And this is the output, not the output, the standard, or the exit code, I think. So this is the exit code being sent through last result. So where does the actual content of the file come in? Alright, it looks like this is looking for the log collector file, which I believe is probably the output of the yeah, I don't quite understand what this is. So during the loop, if you get a -1 or a -18 or a minus or 0, continue and go through the loop. But there's nothing like breaking. All right. Anyway, got a. Let's see what this function is doing. Opening the file, getting the file stat info, it's not closing the file, which I suppose means it can be handed over to to whatever called it, right? So let's see. If the file has anything in it, it returns the file, I guess the contents, the open file and the inode, otherwise it returns nothing and the inode. Okay. So that was what we were doing down here. Got a file and an inode. And then handle rotation or init. What does that do? There's no docs, okay. I'm not sure I fully understand what is happening here. If rt.logCollector inode is 0, so it sets the inode, otherwise it rotated it and resets it to 0. The read offset, I guess, is set to 0. Okay, I guess that's just to make sure that it's not, it doesn't need to read from further in the file. Okay, so we can skip that for now. Contents of the file, empty byte slice. Okay, so this is where it's reading the contents of the file. Closes the file. Alright. And it decides here whether or not it needs compression. Upload the log. Okay, this is probably where it goes into the config map. Let's see. Upload log. It takes the contents, whether or not it's compressed, the daemon config, and the daemon runtime. Man, I want to complain about how hot it is here, but I know like 99% of the United States is freezing at the moment, so I won't do that. But it's a little warm in here. Alright. So this is an inline function. Alright, let me try to parse what this is actually doing here. That's... Alright. Function, anonymous function, returns only an error. Inside the function, we get the file integrity instance. We get the log config map. Log from the instance and the config map name and the contents. So we're passing it in the contents. So this must be building a config map. Let's see. Yeah, okay, that's what it's doing. Setting some annotations, if compressed. If compressed is true, it sets an annotation common.compressed logs indicator label key empty. So it's just the key exists. It's not like not a key value, which is fine. That's a normal thing that you see in OpenShift and Kubernetes. So what I was missing, I believe, is that there should be an annotation common.compressed log indicator label key on any config map that's been compressed, I think. If that's the case, that might be what we need for what I'm working on today. That might be the last thing that we need. Let's write this down. Common.compressed log indicator label key. If that key exists, probably we should be able to find it in the config map with the results. And just know that we immediately have to unzip the results. And I think my dog is asking me to go out in just a second. I will be right back. Give me a few seconds. Alright, dog crisis averted. Well, that's life too, isn't it? Unedited raw stream with doggy bathroom break, right as we were getting to the meat of what it is we're looking for. So let's see. What I was saying, I think, is that this common.compressed log indicator label key, which is not a super helpful label. Should exist in the annotations. Annotate file change summary. What's that do? Because there's annotations there too. Okay, so this is the output of the aid stuff. And this adds the annotations too. Okay, so that's just adding more annotations. That's fine. So where were we? I think I lost it. Here we go. Yeah, so we have an annotations array here, or sorry, map here, map of strings, strings of strings, and if it's compressed, oh, that's, you know, that's smart, because this is going to be a map of string keys and string values in this map. Currently, the fact that it's compressed as a Boolean, that's why they're not using another Boolean. They're just saying if this key exists, it's compressed. They don't have to shove a Boolean into the annotations. And they update the annotations with the other stuff. And they create the config map and return that with the annotations. Okay, so they've gotten the config map. And then they config maps create a config map. So they create a config map named something. Let's go back to this. They create a config map named whatever config map name was. Okay, this here, conf.log collector config map name. That, I think, gets created when the daemon is run, which was in the pods. Let's look at the pod here. That's probably this, and then it gets the name off of that. So ADS example file integrity log collector config map name. Okay. We have one config map. It's not named the same thing, but this might be a config map that was created from the other config map. So we got a config map that says, oh, this is just the aid conf. Okay, never mind. This is saying what we're scanning for changes. So far there aren't any. No annotations. So that didn't help, but we can continue down this path. We have a config map name called that. So let's see if we can find out where that's referenced. Let's see. That's where it's set and used to get the information. Alright, I would have thought that the config map controller was using that name, but apparently not. But now that we know that that's where the temporary config map is being created, we can go look at the actual config map controller. Let's see what this is doing. Okay, here's the config map reconcile loop. Gets an instance. I think this is what we want. We want the integrity log config map. So this, oh man, this just looks for all the config maps in this namespace, which or is following all the config maps in the namespace, which that leads me to another bug I think that I found last time I was looking. If you try to install this using OLM and select all namespaces, it has to look through every config map in the cluster, or at least in the spaces it was installed. So let's double check on that. Config map. So the config map controller may be looking for all config maps in scope. And we don't want that to happen probably. But that's easier, I suppose. That means just kind of watching every config map for changes. You don't have to know the name. Yeah, that's a lot of code to watch for sure. Yeah, so that's why it's not using this name down here, which is unfortunate. I mean, we've got the value of the name in the operator. It may as well just be going to grab that name, but it doesn't. It grabs any of the config maps and looks for looks like label. So in this case, it's common is integrity log with the labels. Let's see what label it's looking for. It's looking for a label with integrity log label key. And it's doing the same thing it was doing in the other instance. This is the label key, so it's only just looking for this. If it tries to return that label, it doesn't care what's in the label, and in fact there's no value within the label because it's a map with an empty string, right? But the key exists, so then it knows that it's the thing, which is kind of a cool pattern. I like the way that's done. All right, so I believe handle integrity log is what we're looking for. So gets the owner referenced. It's the name of the node. Gets the file integrity operator object. File integrity object. That's the CR we're working with. And pardon me. There's a copy of the file integrity object. is integrity log an error? That would be whether the log has returned saying that something is wrong. Integrity is not in, does not have integrity. I don't know. File does not have integrity. I don't know. We check because it contains the error annotation key. If it doesn't contain the error, that's not what we're looking for. We have to have an error for compressed results, right? There's a scan results. Okay, that's updating the integrity object, saying that there's been an error, which is good. There's the node status object. There's the config map for a failure. So let's see, that would be I think it's providing, okay. Okay, yeah, so I think this is doing what we think it's doing. Where were we? Here, okay. No. I lost it. Where were we? Here we go. Yep. Okay, so if it is a failure, it gets the failure CM by passing it the config map that we've already got. That becomes the failed CM. I need to open this. Can I open this to the side? Open. What happens if I say control? Nope, that didn't help. Alright, so yeah, it takes the failed, the temporary config map, and it creates a new config map with the name, namespace, labels, and annotations. Annotations, that's it. That's okay. And the data. And it returns a new config map named whatever dash failed with those annotations. And delete some labels. Mark it as a result. Okay. So we've got this failed config map. What happens with that? We create a new config map with the failed CM. So yeah, that annotation, the common compressed logs indicator label key, should exist in a compressed config map. So I suppose now I need to try to figure out how to make a compressed config map to verify that. But I think that's good. I think that's good to know. So that's a good note. So what we can do is we can look at the results. If there is a failure result, look at the config map, and if that key exists in the config map, then we know it's compressed, and we can decompress the data when we get it out. So it's still up in the air how we want to get the data out. I think Maybe we could do some kind of log, like sidecar log forwarding or something, where we watch to see if a failure config map is created. If it is, read it, unzip the contents if it's zipped, and forward that. That would make it at least a readable, human readable output. I wonder if that's the best way to do that. Because we're not looking at logs from the containers or the pods. That's not useful. We need some way of getting the fact that there's been a failure, and kind of marshaling, or not marshaling, looking that up as a human to see what failed, right? Or automating, you know, the return, automating the fact that it failed. But where's that going to happen? Is that going to happen on cluster? Are we going to notify in some way, toss that out into FluentD or Splunk? How would that work? I mean, it's not going to be a sidecar, right? We're not going to update the operator, but maybe it'd be a little pod that just watches for results. I'm not sure the best way to do that. Let's write some of those down though. Maybe we can have. It's not going to be sidecar because we don't want to change the operator. Maybe pod watching. A pod watching for failed CMs. Looks for the compressed indicator label and decompresses if compressed, and maybe forwards. Yeah, that could work. We could have it just write its log into write the uncompressed config map, like the log from aid, into its own standard out, and if we're watching that for something with FluentD or Splunk, that could work. How else would we indicate that there's a config map that needs to be removed from the cluster? Something that needs to be moved into another place. How would one indicate that? I don't know. Where would we store it? That's probably why the guys who write the folks who write the file integrity operator are using on cluster config maps. How do they get the data out? I don't know. But anyway, we know that because of this compressed logs indicator label key, we should be able to know if a log is compressed. So let's see. Okay, so we got a file integrity node status, which means our scan has succeeded. Let's look at it. It says the scan succeeded, so nothing was different. Everything was fine. Alright, so let's see if we can go hop into this VM. I think there's a way to get into the VM with CRC. Status CRC help. Remember, we're using code-ready containers, so our OpenShift cluster is effectively a single node cluster running within a VM. I think I can SSH into that VM. Maybe. Alright, maybe it's not as easy as I thought. What about OC debug? Maybe we get node bug. Okay. There you go. Alright, so we're on, I think we're on the host of the OpenShift cluster node. So if we were to go to like, resolve.conf, and let's just fill it with a bunch of junk. Okay, before we do this, let's figure out how the log collector decides that it needs to compress a file. That was at the top here. It needs to be compressed. How does it decide that the file needs to be compressed? It needs compression if the contents is larger than the maxed uncompressed size, which is 1 megabyte. Okay. How big is the resolve.conf? Nowhere near 1 megabyte, right? Yeah. K's. Let's see, can I do 10p? Yep. Let's do 10,000p. So that's a very big resolve.conf. How big is that? Not quite a mega, not really a tenth of a megabyte yet. All right, let's do this. Say about lots of hellos and let's say 20,000 paste. There. All right, so that should be a 7 megabyte. Hey, is that a? You're saying is it a open parentheses in the wrong place? Stealth King, where are you looking at? Or is this harking back to that previous joke? So that should trigger aid the next time it runs. Now we have a resolve.conf that is gigantic. The last time aid ran. Oh, maybe we do. Let's see. You're just messing. Nice. Good callback. Fully 2 hours later. That's impressive. Good job. So we have this file integrity node status. When did it run? Where's the semicolon? There's surprisingly few semicolons in this, thankfully. Okay, so it ran at what, 40 after? So we gotta hang out for like 9 more minutes. Hey, Beef Viper, hello. Welcome. I don't know if you're here for the programming stream or if you were looking for Dwarf Fortress, but today it's a programming stream. We're trying to figure out some stuff. Take a moment for the folks who are here if they're new. We're point of this stream, I think, was to kind of show off what it's like to be a real software engineer, unpolished, unpracticed, unprepared, to differentiate kind of from what you might see online in presentations and whatnot. Hey, Dr. Phineas, well, you're usually here for Dwarf Fortress, but today it's programming. I wanted to differentiate between what it's like to really be doing the job and what you always see on Twitter and in these presentations where people are accomplishing amazing things, and it can kind of look like you'll never be able to accomplish that, or you're not quite as good as they are, not as polished. So this stream, this one that I'll be doing Tuesdays and Thursdays, I think, called Practically Programming, is to showcase what it's like to be a software engineer, an SRE, and have been in the business for almost 20 years and still have to look things up and still struggle to figure out where things are. And the folks who have been here for the last 2 hours tracking down one single location to try to identify how this file gets zipped or not can attest to that. It's not as shiny as it appears online, but that's okay, and it can be that way for everybody. So yeah, today is a work and examples programming stream, and Monday, Wednesdays, and hopefully Saturdays will be Dwarf Fortress, and then we'll have I'll have a shameless plug for a retro gaming stream that I'm going to do, because I got this thing hooked up to my computer the other day. I don't know, can you see it? The Nintendo in the corner there, so the original console. So we're going to be doing some retro streaming too. So, yep. Oh man, you can see behind the curtain. Pay no attention to the man behind, or the curtain behind the man. There we go. Oh, that was close. Giving away all my secrets. There we go. Better. Yeah, so we'll do some NES and some Super NES because I've got both of those consoles. I think I'm going to play some Final Fantasy, the original one, and then maybe Final Fantasy 2 and 3. We'll do some playthroughs. Maybe not all the way through, but we'll do some playthroughs. But, right now we're killing some time because the last scan ran at 40 after. I'm guessing one... Hopefully that wasn't like right immediately after we started. This thing hasn't bombed out, has it? No, still running. So we should get, I think we'll get a scan again in, well no, I think we should have just gotten a scan. Or no, we'll get a scan at 55 after. So hopefully, if we get a scan at 55 after, then we should have some output to look at. What am I doing here? See, this is also the unpolished, unprofessional. Can't keep track of the terminals, too many windows. This is what it's like to do my job. A lot of guesswork and tracking down. And yeah, I want to say I'm a software engineer. You haven't seen any coding yet today. We're 2 hours in, so I don't know. There needs to be another title. Professional code sleuth? I don't know. All right. Still got that same file integrity. We'll just watch this, huh? That should let us know when it changes. Yeah, that is why we have VS Code for sure. You know, I don't want to like shill for Microsoft or anything, but I gotta say VS Code has definitely made me a better programmer. It is such a good editor that I came up to speed with Go very quick. Quicker than any other language I learned. Part of that is experience, but part of that is also just the Go language server that's built into VS or that you can install into VS Code. It made it so easy to learn how things worked, gave you hints and everything. It's worthwhile. I'm sure any good IDE is like that, but VS Code is certainly the best I've ever used. B5RX, what language do I usually program in? The team that I work with now does like 90% Go, and maybe 85% Go, 12% Python, and a little bit of Bash. But previously, most of my experience had been in Python and some in Ruby. Honestly, it was Ruby and Rails because I haven't done anything with Ruby without Rails. But I didn't feel comfortable as a programmer at all when I got hired. I was definitely an operations background. And, you know, I've done basically nothing but programming for the last year and a half, and I'm learning some Go, and it's been good. It's been real good. I think my laptop just shut off because I unplugged for too long. There we go. Use Visual Studio for C++. Yeah. How do you like it with C++? Yeah, Python's great. I like Python a whole lot. But I also got to say, I like Go a whole lot too. I didn't particularly care for Ruby. Not for any particular reason, it just didn't speak to me as well. But Python feels like it makes sense. And Golang is, I don't know, it's fun, it's powerful, it's cool that it can be compiled. I know you can do that with C as well, but I like that it can be compiled into a binary that just runs. Like, it's pretty neat. Stealth King, you're going through the Python training and started learning HTML through Udemy. Nice, that's great. That's a good mix. HTML is where I started way back in the day. Back in maybe 1998, I started building. Maybe 97 probably. I tried to build a little website on AOL way back right after I got out of high school. Hadn't started college yet. It was the summer between, and I was on my uncle's computer trying to build a website in AOL. I learned a little bit of HTML. That was the start of all my programming. Nothing before that. So I didn't take any programming in college. Didn't take any in high school. So using plain old Visual Studio. Yeah. Hey, I mentioned it earlier. Use the tools you like. Use the tools that work for you. It's a lesson I learned from my buddy Nate, and I wasn't there when I met him and he started saying those things, but he pulled me in the right direction. I'm no longer like a Vim diehard. It's I use Vim, but I don't care if you use Emacs. It's great. You're 43? Yeah, I'm 42. About to be 42. What year is it? 2001. Yeah, I'm about to be 43, I guess. So yeah. We are very close to the same age. Yeah, did I say 2001? I meant 2021. Yeah. Trying to do the math, like figure out how old I am. IntelliSense makes everything easier. Yeah, that's sort of what how the Go language server works. Just being able to like look up, like this is a byte slice, and It gives you, I mean, in other more complicated things, I don't see any examples here, but it gives you a bunch of information about what they are and how they work. So it's, there we go. Yeah. So it gives you kind of what it is, the package it belongs to. It's kind of nice. Hey, you know, Stealth King, that's fine. It really is. I was in, I did help desk stuff for a very long time. I think I got my first systems administration job when I was 30, and didn't learn to code until maybe 4 years after that. So I've been doing, I guess I've been coding for about 8 years, maybe. It all came later. I didn't learn it in school, so picking it up now is just fine, you know. All right, it looks like we passed the time. Oh, there we go. See, I was gonna say it passed the time for the check, and look, it says status failed because we updated the resolve conf inside the node. So now it's gonna say it's a bad resolve.conf. So let's say so you get file integrity, node status example. Yep. So it's gonna say that this master has it's failed. Let's describe it. Can we confirm it? Is this going to confirm what we thought? Yeah, it's failed. We have a config map here. So this is going to be the config map with the log results from aid. I don't see anything in here that indicates whether or not that was zipped or not. Yeah, nothing in there. So let's look at the config map itself. There we go. 2 hours and 4 minutes in. Let's see if we're successful in identifying, not fixing, not dealing with, just identifying where the problem is coming from. Okay, it looks like well, no, we're not helpful. Or not, we're not helpful. We're not, we didn't solve the problem. Because I guess it's not just the resolve.conf. It's clearly saying the resolve.conf has changed. So it's working correctly. But this config map is not, this log is not too big. So I need to do something to make this log too big. Yeah, there's, okay, yeah, look at that. It even saw that I SSH'd in. That's pretty neat. This will be a really cool tool if we can get this to work. If we can get these logs out into something, it'll show us anytime anybody SSHs into the host, if they change a file. But I need to make this file too big, and it's not too big yet. Let's write this out and see what we got. We're going to get it as YAML into yeah, we're going to need some more content. That's only 3K. We need another 97,000 K. I'm not sure how to go about doing that. If we need to make this file bigger, that means we have to have a bunch of entries, which means we have to change a bunch of files, which means it's going to hose our node, maybe? So let's look at the config map. Let's see what we're actually looking for. So all right, so we're including anything in boot, permissions in root. excluding the source, excluding temp. We might be able to. Yeah, let's see if this works. Maybe we can change this to include opt and then just write a bunch of files in opt, rescan, and then delete all those files. Maybe that'll work. What was the name of this config map? Let's see if that works. Oh man. Nano. Killing me. Alright, we're going to include opt. I suppose. Suppose that'll work. I gotta remember how to write with nano. Write out. Alt O. Nope. Control O. Sure. And then Control X. Yep. Let's see if that worked. Yep. Alright, so we're including everything in opt. Did that redeploy the pod? It did not. So updating the configuration didn't change anything. Did this thing even see that I updated the configuration? Yeah, it saw it. Saw me change the config. We're gonna go ahead and delete. Yeah, we're gonna delete this example and then recreate it. Possibly, maybe. No, I don't know if that's what we want to do. Let's delete the daemon set. Stop. Yeah, I think I probably need to kill the pod, and then it'll probably work. Oh, come on now. Here we go. Let's delete this pod. So now I got a new pod coming up. There we go. 8 is reinitializing. That's good. That means we should have a new database, which should include all of opt. Then I think we can touch a bunch of files, and I think it'll complain about that. Okay. So let's do the debug again. All right, so what we did is the debug node opens up a pod on the node with some special privileges, and it's mounting the host file system as /host, right? So inside the pod, or inside the container, we have this directory host. And if we chroot to that, change root, it's like we're on the node. We're actually on the node itself. So now we can go into opt. And oh look, there's a kube config, CNI. Oh, let's touch a bunch of files. Yeah, now we got a whole bunch of files. And actually I should have done an echo. There we go. Yeah, now we got 100 files. And each of them has hi in it, I think. Oh wait, that's not 100 files. What did I do? There's 100 files. Weird. Or something like 100 files. All of them have the word hi in it. Alright. Now we'll get back out. And we should watch we got the file integrity. We need to watch the file integrity node statuses. Then delete the failed node status. Good. And then let's go ahead and change the change the time frame so that it scans more frequently. We'll have it scan every 5 minutes. That'll make it easier. That was set in the file integrity object. Hold on, I need to change my editor. This is not going to work. There we go. That's a little easier. Why is my editor set to nano? That's odd. Alright. Here's the grace period. I'm going to change this to 300. That'll be every 5 minutes. And I think daemon set has the new interval. Very nice. And there's a new node. Okay, new pod. So that pod should have a scan interval of 5 minutes now. Okay, the aid check returned to status of 0. Which is good. So now I need to go change some files and see if in 5 minutes if it reruns again. Let's see. Yeah, OC debug. You can tell I'm at the end of the day, man. Brain's not working anymore. Oh, look at that. There we go. I think I also did this. Why not, right? Okay, so those files should be different now, and edit the resolve.conf. Oops. There we go. I might have accidentally deleted something out of here, but that's fine. There we go. Now we got the resolve.conf back to normal, so we'll see if the next scan turns up anything. I should get one in a bit. It's going to do every 5 minutes. Yeah, so this is the kind of work I do. It's not the kind of work everybody in my team does, but we all do kind of different things. Right now, this is part of what I'm charged with investigating, figuring out how we can get this information out of this operator and into something we can process, you know, as in an automated fashion. So that's what I'm working on today. Hope everybody's having a good Tuesday while we wait for this thing to roll over. We should get at least A status. Seriously, we should have an A status already. Okay, it's been running 4 minutes, 8 seconds. I bet that means in a minute or so it's going to run again. Let's see what it says when it runs. We'll give it a 4:15, 2:15, no, 6:15 Pacific time. Come on, come on. Well, yeah, it's been 5 minutes. No changes in the logs. Let's see. We got a file integrity node status succeeded though, so that leads me to believe that this is the first run, maybe the database. Let's see. Yeah, it looks like, I mean, it just worked. It was fine. So let's go ahead and go back in. Maybe poke around a couple other things. Actually, maybe we could look up the aid syntax. That'd probably help. Aid syntax. Yeah, it looks like our config file was correct. What was that? Is that the old one? Yeah, I think this is the old one. Yeah, let's get rid of that. Okay. We're going to look at the config map for the example file integrity. Oh, it was rewritten. So that is not the appropriate way to change the config map. So let's try this. Or try this. Let's look at the documentation. How about that? Okay. Let's get the default config. Okay. We'll change this to include opt. This is what we were attempting to do. Include opt in all those weird files that we changed. And, well, we didn't give it a rule either, so that was probably part of the problem. So we'll give it a rule. Create a new config map. Yep, and this includes our opt. Hey, Steven, welcome. Glad you could make it. What time is it there for you? It's 9:30? Oh, man. That's late. Said I was offline. That's weird. I don't know. I've been here for about 2.5 hours, so Twitch has been behaving weirdly today, though. I know Mello was having some issues with it, and Adam McGeekheim was here a little bit earlier too. So we just got this file integrity CR, the aid conf, right? And then we're gonna want to point to a different config file. So using the Twitch app on the Fire TV, yeah, maybe. All right, let's see if we can edit this file integrity object, CR, and we want to give it a config with a name. I think this is correct. Let's see, config. Name. There we go. I think that's what we're looking for. Yep. And we need to annotate the version. There's so many opportunities to misspell something here, and everything goes wrong if you misspell it. Okay. Let's see if that made it reconcile. Yeah, alright. So it's reading our upgraded... But there we go. I got a misspelling. So let's re-edit. Let's see, where did I make that edit? Oh, I just killed the operator too. I didn't mean to do that. Yep, that's supposed to be a Y. Override example file integrity. Yeah, that looks right. Okay. So that should be okay. Let's re-annotate to version 3. Okay. Nice. Now, did that... That might be a valid error. Who knows? Well, we'll see in a second, huh? So, Stephen, this is the file integrity operator, and it runs aid inside of pods on each node in the cluster. And it watches a selection of files based on some rules that we provide and sees if they have changed. And if they have, it writes out a config map saying and something called a file integrity node status, saying that it's failed the integrity check and that X file and Y file have changed. This was the original SHA. This is what exists now. That kind of thing. So it's a good. Apparently, it's a good security tool. And what I'm trying to do is figure out how to get the output of the logs for the aid out of a config map and into something more useful. And part of that is because it's sometimes the config map is compressed, and I'm trying to validate that the operator works the way that I think it does. So yeah, it's definitely security related. So it would work just fine out of the box if you're running 1 or 2 or 3 clusters kind of manually, but on a scale of hundreds or thousands, we need a way to get this data out in a machine readable format. Right now it's text, and sometimes it's gzipped and sometimes it's not, so we're trying to figure out if there's a programmatic way to identify that it's gzipped, and then maybe we can also write a patch or something to submit the output as JSON or something. So I can show you. We have this default config map. That's the lock file. Wrong thing. Yep. So this is the aid config file. So the things we're watching are like all of /boot on the node for pretty much any of this: SHA, type, permissions, SD Linux attributes, other things, ACLs. We're looking at, I guess, the parent of root, so the / for any permission changes, root for the same thing, opt is one that we're testing right now, and then host root user and etc. So, and we're trying to ignore some OpenShift stuff, things that is written to that we expect to be written to. So, yeah, it watches the host file system on the node. And right now we're using CRC, so we just have a single node, but it could watch all the nodes. So. Thanks, man. I appreciate that. I'm glad. Hope you find it useful. And I'm enjoying doing it. It's nice to have some company while I'm working, which is kind of nice. Yeah, I think that's maybe the privilege escalation or people tweaking files they shouldn't be is one thing. It could also be just drift, right? If your change management starts to change files you don't expect, or this new RPM or an update changes something in a way that you weren't prepared for, it would catch that as well. I think those are probably the two main use cases: malicious actors or drift. One of the cool things is watching the root bash history. So as soon as I did an OC debug and hopped onto the node, the very next scan said, yeah, the bash history has changed. Somebody was on this node. I didn't, I could have not necessarily done anything. I could have just looked around, but now we know, right? The bash history changed. Somebody was on this node. So that's pretty neat. This is not my work at all. My job is to kind of look at this operator, see what we would need to do to incorporate it into OpenShift dedicated. And right now, I think we've got to the point where we think it's worthwhile, and I'm trying to figure out how to parse the output in a way that makes sense for thousands of clusters instead of 5 or 10 clusters. So. But I need to figure out if this operator is working the way I think it's working. And we're approaching 3 hours, and we're just now getting to that point. So this is a very good example of unpolished, trying to figure stuff out, and not the stuff that you see on Twitter and in presentations. Exactly what I was going for with this stream. So 3 hours in to just verify one thing. We did hunt it down, though, so that's at least useful. Hunted it down, now we're verifying. So. Okay, so we've got a new file integrity node status that succeeded. I believe. When did this run? Maybe. OC describe. Sure is hard to type file integrity node status. This ran at 29 after. So yeah, this just ran. So it should be using our new rules. So now if I OC debug the node, now I can tweak a bunch of stuff and hopefully, yeah, hopefully we'll see some response. So. Okay, so we got extra lines in those files, which we are. Maybe we're not watching what I thought we were watching. Let me go back and look. Where are those aid rules? No, yeah, okay. Host root opt for the content. Yeah. Right. We also have bash history, so that should have changed. And we'll edit the resolve.conf again. That's interesting. Something is not displaying correctly. Well, we'll see what happens. Hopefully I'm not breaking our cluster here. That would be unfortunate, because it takes a little while to spin up another one. Did it just fail? Oh, that's a... That was at 30. Okay. So let's keep an eye on it. It should probably rescan in a minute. So we got about a minute, and I'm hoping it's going to say it failed in a minute. I'm gonna see a failure, and hopefully it's a very big log because of all those files in opt. So it should be scanning in a minute, any minute. Oh, I guess not. Let's oh. Just as we stopped looking at it. Okay, so it did fail. That's perfect. So let's take a look at this node status. And we have a failure config map right here. Well, except despite it being lots and lots of files, it's still not gzipped. So let's see if we can, let's write this out and see how big this is. How many more files we need to create. $62K. Oh man. So we got to create a bunch of files to get this to flip out. But okay, that's fine. That's fine. We have Bash. Bash is our friend. We're gonna, let's see, 62K. We need 10, 20 times the files. So there's about 100 in there. We need 2,000. Let's go ahead and make 10,000 files and just fill them, huh? All right. Yeah, exactly. We've been using for loops all afternoon. All right. Let's make it 25,000 files. Did I see CH root? I didn't see CH root. I'm still in the host, still in the pod. Okay, let's actually CH root into the host this time. That wouldn't have done us any good. Yeah. Okay. So now we'll just go ahead and do this same loop again, but we're going to create 25,000 files or echo stuff into them. There we go. That. You think that'll trigger him? Let's be safe. We'll do 100,000 files. Yeah, good call. Good call. Luckily, it's just a VM. I was wondering, there's like the back and forth. That's pretty good. I like it. I assume I'm guessing you account for all 2 of my viewers at the moment, but we were going strong there earlier. There were about 8 people, 9 people at like 8 o'clock Eastern time, maybe. So that was kind of nice. Had a good group of people. All right, so we got plenty of files now. You're using IRC to talk to Twitch. That is awesome. That is awesome. Thank you. Oh, and thank you for the tweet. That's great. Thank you. I appreciate that. Yeah, I'm going to try to do this every Tuesday and Thursday. Just make it a regular thing. And yeah, it'll be good stuff. Let's see if we can find this node status again. Still failed. This is probably the old one. So we're going to delete the old one and the old config map. Okay, I guess that cleaned it up. Okay, that was at like 40, so we got like 4 minutes, I guess. It'll take a little while to run. I probably should have made that like 60 seconds, but we'll do this. Yeah, so hopefully at 45 after, or 15 till, we'll get another run, and it'll say it failed, and this time maybe it'll be compressed, and we can verify the thing that we think is happening. That's what we're trying to figure out. There's when this output, the log of the failure, is written down. If it's a certain size, if it's too big for etcd, it's got to be less than a megabyte. Then it gets compressed. So I've been trying to make this log bigger than a megabyte, so that we can compress it to check and see if there is an annotation on the config map that is letting us know that it's compressed. And we think it's going to be there, but I haven't seen it and haven't been able to prove it yet. So I need to prove that it's there, and if that's the case, then I think I've succeeded, at least for the stream, in identifying that there is a thing that can tell us, and there's a thing we can do to identify when that's happened and decompress the information. So it took about an hour and a half to figure out the operator and how it was doing the checking and where it was compressing the file, and the fact that it had that annotation, and it's taken about an hour and a half to try to replicate a log file large enough to get compressed. So here's hoping that 100,000 files will trigger a big enough alarm. Yeah, we're getting there. We're getting there. I'm enjoying this this music, man. This is the chill EDM station on Pretzel Rocks again. It's good stuff. Yeah, I know you've said you haven't had a whole lot of success, but man, the EDM station is where it's at. All right, one more minute, maybe a minute and a half. I know what some of those words mean. It's different when it's by itself or when you're using it as bed music. What is bed music? I mean, I don't know about you, but I usually use Barry White for bed music. Oh, okay, fair enough. Fair enough. I'm learning some new terms. Not only am I learning some Go and learning some OpenShift, I'm learning some new streaming stuff. That's right, yeah. That specific song by Barry White is pretty dang nice. I think the first time I'd ever heard it was in an Ally McBeal episode, like 1999 or something. Of all things. Alright, I mean, we should have a node status by now. Yeah, it's right at 20 minutes old. It definitely should be scanning. Maybe it's in the process of scanning. Okay, it is running right now. And it should return a status. Okay, so it runs every 5 minutes, but it doesn't necessarily succeed every 5 minutes. I don't know that I've seen Money Talks But for Chris Tucker and Charlie Sheen, I would definitely watch that movie. Those two guys are like, they fill a spot in my my early 2000s, maybe late 90s Chris. As those two guys in it, that's for sure. Chris Tucker especially, he did some really funny stuff in the late 90s. That was good. And of course, who can forget Fifth Element? He was fantastic. Man, that check is still running. Exactly, right? Super green. Super green. Ruby Rod was a huge portion of the comedy in that movie. It was fantastic. I wonder if 100,000 files broke aid. It's been running for 3 full minutes now. You see the previous runs all returned 12 seconds later. This one's been running for a good while. I guess maybe I should turn it back to 15 minutes. We're about to run on the next scan. Well, that'll be a good test. Let's see what happens when we try to run 2 scans concurrently. You know, after dealing with all the high-performance computing stuff at previous job, I feel like 10,000 or 100,000 files is not a ton of files, but that's a fair point. It probably is a whole lot of files. All right, come on now, anytime, anytime. I guess I broke it. Yeah, I mean, there must be a second one already running, or it's got to have the internal logic not to run another one, or we would have heard something already. Wait a second. One of these should be the operator. Did I accidentally Control-C out of an operator? Well, the pod's still running at least. But maybe nothing's updating. Where? Yeah, Solid, solid. I apparently stopped the operator. Which is not going to work when you need the operator to do a thing. Yeah, that was not smart. Not smart. Yeah, this might take a little bit now. Yeah, helps if the operator is actually running. At least for the copying things back and forth. Okay, reconciling the file integrity status. I wonder if that includes the node status. Nope. Yeah, it's still like 10 seconds behind, or 10 minutes behind now. I wish I knew what was going on here. Let's see. Certainly, the pod's still, the process is still there, but I wonder if 8 is dead. Nope, 8 is running. And has been for a while. It's okay, so it's yeah, it's probably just yep, there's my comp file. So it's still chugging along on all of these files apparently. That's fine. That's fine. Maybe it was a little overkill. I did calculate that 25,000 probably was enough and went with 100,000, but whatever. Sometimes you gotta throw things at the wall and see what sticks. Usually it's those little gel octopuses, right? Little toys. Throw it at the wall and it does its thing down. Anybody remember those? Come on now. 12 minutes. Shouldn't take 12 minutes to scan 100,000 files. I may have broken this. This is fine. It's the whole point of this stream. So we're not all perfect. Maybe I broke it. I'm trying to get this figured out. It's going to take a little while. That is okay. Well, I'm hopeful that it will return something before the end of the stream here. I think I've got another 7 or 10 minutes in me. And I gotta go do some things, but I just want to get to this. We need the resolution here. We need the resolution. I don't suppose it should take this long, but who knows. I know the CPU was definitely chugging away. I wonder if we can open a browser without giving away too much. And can I get you guys to see the browser? That is the other thing. Nope. Apparently not. Let's try with a different browser. That's not what we're trying to do. Nope, I guess not. We'll try to figure that out for next time. I also got to invalid login anyway. We're gonna try to look at the console, but still running the check. Still running the check. I wonder if I need to kill the pod. I mean, 8 is running. It's struggling through. It must be doing all those SHAs. Trying to compare each of those files. Sure is struggling. Coming up on 20 minutes. If we get to the 20-minute mark, I think I'm going to call it. We're at 3 hours now in the stream. We'll call it, and we'll just say it's another perfect example of just failing publicly. We didn't figure this out yet, but I'll let it run overnight and see, and we'll have something to report back next time. And yeah, so that's the whole point of this stream. That's the whole point of this stream. Yeah, it is. Definitely, it was 100%. It was progress, and failing is not bad. It's just you try and you do a thing, and it works or it doesn't. And if it doesn't, that's technically a failure. But you know, that doesn't mean you're doing anything wrong. So, hey, Chronover, just in time for the very end of the stream. Sorry, buddy. Oh, you're here for more than 2 minutes. Okay, cool. Glad to see you, man. Yeah, so yeah. I was gonna say, you know, there's all the polish, there's all the professionalism and everything that you see in presentations and online and Twitter, and you got to remember all the work that went in behind the scenes, the stuff like this today, the, you know, testing and trying and doing a thing and trying and doing a thing again, and maybe it didn't work, maybe it did, and but that's okay. That's what leads to success eventually. And it's okay to fail in public. It's okay to fail out loud. I think there's a podcast. I found some other ladies had already claimed that phrase, and they're pretty. Seems like they got a pretty good podcast about being honest with yourself and caring for yourself and not keeping yourself down. Right? It's okay to fail out loud, and just because everybody looks like they're doing everything perfectly, that's not the case. They're also trying, and you know, it's taking them effort as well. So yeah, Chronofer, that's what this is. This was an opportunity to kind of show what it's like to really be programming, and how it's not all fancy presentations and profile building on Twitter and LinkedIn. So I think I'm going to keep doing this. This is the first episode, but we're going to do this, I think, twice a week to show what it's like to just kind of learn as you go, you know. Dr. Phineas, good to see you. Thanks for stopping by and hanging out. How it's not hackertyper.net. I don't know what that is. Hackertyper.net? Oh. Cool, yeah. Fair. VS Code is my jam, man. It's no lie, it's made me a better programmer, that's for sure. So, well, all right, that's 5 o'clock. We've been running this aid for 20 full minutes now. Hasn't gotten us anywhere, so I think we're going to let it run overnight. We're going to see if it finally finishes indexing these files, see if we can prove the hypothesis we've been working on for 3 hours. But I think we're made some good progress. So thanks everybody for hanging out. Thanks for stopping by. I really appreciate it. I'm definitely going to do this again later this week on Thursday. And I think we'll just make it a Tuesday-Thursday thing. We're going to shoot for 4 p.m. Pacific time, because that works for a bunch of people, I think, for the target audience. And yeah, thanks again. Check back next time, and I'll see you around. Everybody have a good evening. It was fun. It was great to see you all too.